Okay, I guess this is recording. So this is the notes, part 2, adding and subtracting rational expressions. We're talking about complex fractions and example number 2. So I'm live in class today. We had somebody say that they would find an LCD, which is exactly right. Does anyone know what the LCD is? Just a reminder, I'm recording, so if you don't want to be on it, that's okay. Okay, so here's the thing. Just watch what I'm about to do. I'm only putting x. This becomes x squared minus x over x to the third, x squared minus x over x. That would simplify into x squared minus 1 over x squared minus 1. So we said LCD of x, but if you notice, we didn't actually solve any of our we solved one fraction. So we want to think of something a little bit more than just x for LCD. So I'm going to back up. I'm going to erase this. So it wouldn't just be x. It would be x to the third. We want to use that least common. Remember, really least common denominator, we're talking about things that are like almost greatest. So what we could have in common. We can never subtract something from a problem. We can always, multiply to add something to it. So if we do x to the third, just showing you here, x to the third, x to the third. Now I have x to the fourth minus x cubed over x cubed. And then x to the fourth minus x cubed over x, which will lead to x to the fourth minus 1 over x to the fourth minus x squared. So right there, because I put that third, now I'm able to get rid of the fractions. So from here, x to the fourth minus 1, x to the fourth minus x squared, can I simplify any more? Yeah. You can take an x squared out of the bottom. That's a good start. So let's do that. Let's take it. So we've got x squared, and then we have x squared minus 1. What about the top? Can I simplify that?
Yes.
Into what?
It's a perfect, it's the square thing. It's the
Good.
x squared minus 1, x squared plus 1.
Okay, x squared minus 1, x squared plus 1. Yeah, it's called difference of squares. All right, and now I've got an x squared minus 1 on top and bottom. And then I'll be left with x squared plus 1 over x squared. And I cannot cancel out the x squared plus 1 and the x squared. Like, you can't just say, oh, x squared and x squared, I cancel it out because of that plus 1. Anytime you add or subtract a number, okay, it's kind of like, let me tell you about my best friend.
Oh, okay.
So, like, you can't go anywhere without your best friend. You can't go anywhere or do anything unless that has something in common. Okay. All right. Any questions? Anyone need more time? Go through the last example. Okay, last example here.
Oh, wow.
So this is bringing it back to negative exponents. So what I kind of want to show you is, just as a reminder, maybe you can help me out. X to the negative 1 would be what? What did we do whenever we had this? Yeah, go ahead. 1 over x. Good. We flip it, and then it changes the exponent into a positive. So if I had 7x to the negative 1, that would be the same as saying 7 over x to the first. So what we're going to start with on a problem like this is we're actually going to change all the negative exponents into positive exponents by moving them into the denominator. So this will be 1 minus 7 over x to the first minus 18 over x squared over 1 minus 4 over x squared.
Oh, I got this one. The least common denominator is x squared.
Good, yeah. Least common denominator is x squared. LCD is x squared. So I'm going to multiply by x squared on top and bottom. And I'll end up with x squared minus 7x squared over x minus 18x squared over x squared over x squared minus 4x squared over x squared. Now, some of you will probably not necessarily have to do that step. You might be able to do some of it in your head. Okay, like, oh, x squared over x, that's just x, or x squared over x squared. I'm just going to leave the 18. But that's kind of like the step in between. So now we can simplify. So this becomes x squared minus 7x minus 18 over x squared minus 4. I guess I should make that 7 so it doesn't look like a 1. And then from here, what's going to multiply to give me negative 18 and add to give me negative 7?
9 and 2.
9 and 2. Thank you.
Negative 9 positive 2.
So x minus 9 and x plus 2. And then the bottom is
A difference of squares.
another difference of squares. Good. So x squared. Oh, I'm sorry, not x squared. X minus 2. Yes, I am human. Drat, I've showed you all.
Ooh, the final answer, I got this. It's x minus 9 over x minus 2.
Good.
Go me.
X plus 2's cancel out. X minus 9 over x minus 2. And that's all I've got for you for today.